Hello everyone. Welcome back to our Python Programming Fundamentals course. I hope all of you are doing well. Today is a special day because this is the final lecture of our Python Programming Fundamentals course. If you have watched all the previous lectures, first of all, congratulations. You have successfully completed the almost entire course. So when we started Python, we might have been completely new to many of you, but today you have reached the final lecture, so that's something to be proud of. Thank you for being the part of this learning journey. Let's make our final lecture an interesting and memorable one. So before we begin, let's take a quick look at the journey we have completed together. According to the PPT, we have already learned variables, data types, operators, decision making, loops, functions, modules, recursion, strings, lists, arrays, tuple, and dictionaries. So let's briefly remember what each topic helped us to learn. We started with the variables and data types. That was our first step into programming. We learned how Python stores information and how different each type of data are represented. After that, we learned about operators, which allowed us to perform calculations, comparisons, and logical operations. Those operators become the building block of every program we wrote later. Then we moved to decision making. There we learned how programs can make decisions using if else, and nested conditions. For the first time, our programmers started behaving differently based on the different inputs. So after that, we'll explore loops. So instead of writing same code again and again, we learned how to repeat a block of code efficiently using loops. Next, we entered one of the most important parts of programming called functions. We understood how large programs can divide into smaller, organized, and reusable pieces. Then we expanded that idea by learning modules and recursion, which made our program even more powerful. Finally, we spent several lectures learning Python's built-in collections, where we learned how to work with string, list, array, tuples, and sets. And finally, we learned about dictionaries. Each one helped us store and organize data in different way, and each one had its own advantages and use cases. Every lecture built on the previous one. Every new concept became a foundation for the next concept. And today, all those concepts come together as we begin object-oriented programming. So, so what will be our today's learning plan? So according to the PPT, today's lecture contains four major topics. First, we will learn how about classes and objects. These are the foundation of object-oriented programming. After that, we will study the important OOPS terminology, where we will understand concepts like inheritance, polymorphism, abstraction, and also encapsulation. So these are the four pillars of object-oriented programming. Next, we will move to the file handling, where we will learn how Python can read information from the files, write information into the files, and manage different file operations. Finally, we will study exceptional handling programs. These programs don't always run perfectly. Sometimes errors occur. So instead of allowing our program to stop suddenly, Python allows exceptional handling. This helps us manage those errors properly. So by the end of today's lecture, you will have completed all the topics planned for the Python Programming Fundamentals course. So now let's begin into our first topic, which is object-oriented programming, or simply OOPS. So according to the PPT, object-oriented programming empowers developers to build modular and maintainable scalable applications. So let's understand what that means. So when we wrote our earlier programs, most of them were small, few variables and a few functions, some input and some output statements. That approach works very well for small programs. But what happens when softwares become very large? So imagine a project containing thousands or even millions lines of code. So managing such software becomes difficult. So this is where object-oriented programming helps us. So according to this PPT, OOPS is a way of organizing code that uses OOPS and objects and class to represent real-world entities and their behaviors. Notice two important words that are classes and objects. These two concepts form the foundation for object-oriented programming. So everything we study from this point onwards, we will be built using classes and objects. So the PPT also highlights some important advantages of OOPS. The first advantage is programming using objects. So instead of organizing everything in our own functions, we organize our programs using objects. So the second advantage is real-world modeling. So object-oriented programming allows us to represent real-world entities from inside our software, making programs more natural, more easier to understand. So the next advantage is reusability. So once a class is created, it can be reused to recreate many objects, so saving both time and effort. So this PPT also mentions security and easy maintenance. These features help developers build softwares so that is well organized, easier to maintain, and suitable for large applications. So let's quickly summarize what we started in this topic. So today we begin with the final lecture of our Python programming fundamental course, where we revise our journey from variables all the way to the dictionaries. Then we looked at the today's roadmap, classes and objects, and OOPS terminology, file handling and exceptional handling. And we were introduced to object-oriented programming. Up to the PPT, we understood that it helps developers build modular, maintainable, and scalable applications using classes and objects. So now let's move to the most important part of today's lecture, which is classes as well as objects. So using this exact example pointed provided in this PPT. Okay, so let's start with class. Now we have understood what object-oriented programming is. The next question is, if you ask any Python developer which topic is the foundation of OOPS, the answer is almost always be classes and objects. So let's first understand them carefully. So according to this PPT, a class is a collection of objects. So Python also says classes are blueprints for creating objects. Now pay attention to this word called blueprint. So the word is the key. This word is the key to understanding classes. A blueprint is simply a design or a plan. Before constructing a building, an engineer first prepares its blueprint. So this blueprint is called, that blueprint contains all the details required to build that building. So similarly, a class contains all the informations required to create the objects. So the PPT also mentions that the class defines the attributes and methods that its objects will have. In simple words, the class decides what information an object will store and what actions will that object can perform. The PPT also states that a class is created using the class keyword. So whenever we want to create our own classes, we begin with class keyword. So now let's understand what the exact example given in this PPT. The PPT creates a class named dog. So the first line, class dog, this line creates a class called dog. At this moment, no object has been created. Only the blueprint has been prepared. Now the next line in the PPT defines species equal to Canis familiaris. So according to the PPT, this is a class attribute. Now what does this mean? A class attribute belongs to the class itself. It is set for every object created that is from the class. So every dog object will have the same species name. So instead of storing this information again and again inside every object, we store it once inside the class. So the next thing is constructor. So let's move to the next part in the PPT, where you will notice a method named double underscore init and double underscore. So this, according to the PPT, this is called the constructor method. The constructor is a special method which automatically executed whenever a new object is created, so that we don't need to call it manually. So the Python takes care of that automatically. So this PPT also explains that the constructor is used to initialize the object data. That means when a new object is created, the constructor stores the initial value inside that object. So now let's carefully look at the constructor. The first parameter is self. So according to the PPT, self refers to the current object. So whenever Python creates new object, self points to that object using self. So the Python knows which object data is being accessed. So you will see self in almost every Python class. So don't worry if it is feels new today. You will come across it and you will be getting familiarized with constant practice and understanding. So the next thing is called, now look at the next lines. The next lines of the PPT say self.name equal to name and self.age equal to age. So according to the PPT, this is called instant attributes. So unlike class attributes, instant attributes belong to the individual objects. So this means different objects can have different values for name as well as age. So let's remember this difference. A class attribute is set by every object. An instant attribute belongs to one specific object, and this is one of the most important difference you should remember. So now the blueprint is ready. The next step is creating objects. So the PPT creates two objects using dog class. So when these lines are executed, Python creates two separate dog objects. So each object automatically calls the constructor, so that and stores its own name and age. So even though both objects belong to the same class, their instant attributes can be different. So however, they both share the same attribute, which is species. So let's see about accessing object data. So now the PPT shows how to access data stored inside an object. So it's done using dot operator. So the dot operator connects an object with its attributes or methods. Using the dot operator, we can access the values stored inside an object exactly as shown in the PPT. So methods inside a class. So the PPT also introduces methods which are there inside the class. So what are these methods? A method is simply a function written inside a class. Just as an attribute store information, methods define its actions within that an object can perform. So whenever we call a method, the object becomes the particular action. So the PPT further continues with another class example to reinforce the concept of creating classes, constructors, instant variables, and methods. The purpose of this example is to show that the same principle apply to every class, not just the dog class, and no matter what class we create, the structure remains the same. We define the class, write the constructor, initialize the object data, and create our objects from the class. So before continuing to the next topic, let's first quickly revise what you have done here. So a class is a blueprint for creating objects. An object is an instance. So a class attribute is a set by all objects. An instant attribute belongs to an individual object. The init method is a constructor and it runs automatically when an object is created. Finally, self refers to the current object being created or accessed. So now that we have already discussed classes and objects, let's move to the next section where we will learn that four fundamental pillars of object-oriented programming. They are encapsulation, inheritance, polymorphism, and abstraction. So along with the remaining OOPS concept covered in the PPT. Now we have understood what classes and objects are. So the next step is learning the most important concepts of object-oriented programming. These concepts are often called as four pillars of OOPS. So if someone asks, what are the object-oriented, what makes the object-oriented programming different? So these are the concepts you should remember. So let's understand them one by one. So first thing, according to the PPT, inheritance allows one class to acquire the properties and methods of another class. The main purpose of inheritance is code reusability. So instead of writing the same code again and again, we can a new class can you reuse what already exists in that other class. So now look at the example given in the PPT. PPT first creates the parent class and then the child class that inherits from it. So notice the syntax carefully. The child class mentions the child parent class inside the parenthesis. So this single step creates inheritance relationship. So when an object of a child class is created, it can access its own methods and it can also use the methods inherited from the parent class. So this is the biggest advantage of inheritance. We will write code once and reuse it whenever we need. The PPT also introduces. So there are four pillars of OOP. There are inheritance, polymorphism, abstraction, and encapsulation. So first, let's see what an inheritance is. So inheritance is a fundamental concept in object-oriented programming that allows a class or a child class or maybe a derived class to inherit attributes and methods from another class called a parent or a base class. So in this example, it's clearly given that class animal. This class has a constructed def in it with self and name. So we are taking these one attribute which is name from the object. So we are initializing self.name equal to name. And after that we are having a method called info where we will print the animal name comma self.name. So another class is there called dog and which inherits the animal class and def sound self. So this brings self.name box. So if I call d.info, it refers to the all pre-existing method called info which is there in the parent class where and prints animal name comma which is buddy. So the next thing sound prints d.sound prints and buddy box. So the class animal defines the parent class and info prints the name of the animal. So the class dog animal defines dog as a child of animal class. So d.info calls the parent method info and d.sound calls the child method. So this example gives output like animal name buddy and then buddy box. So let's have this example. Notice these dog class, cat class, cow class, and maybe even human class are all part of the animal class. So they all have a ear. They have ears, eyes, legs, and then limbs and the mouth and some digestion properties and which are common. Okay, so which have animal class has and we can and these respective animals can inherit from it. So what are the benefits of inheritance? So first of all, inheritance promotes code reusability by sharing attributes and method across classes. So this reduces the amount of code which we are making. So repetition can be reduced. So models of real world hierarchies like animal, dog or person or maybe even employee. So this kind of thing will be there. So dog is an hierarchy to the animal. So person is hierarchical to employee. So this simplifies the maintenance through centralized updates in the parent class. So this enables method overloading for customized subclasses behavior and supports scalable, extensible design through polymorphism. We will discuss about the next pillar later. So right now, let's see about another important function called super function. So super function is used to call methods from a superclass. So following the Python's method resolution order. So this particular, it is commonly used in child class init method to initialize the inherited attributes. This way, the child class can leverage the functionality of parent class. So here is an example which is given here. So I already have a parent class which is animal, where using init constructor I initialize self.name equal to name. Now def info self prints that animal name. This is fine, right? Now let's have a child class called dog animal. Now the constructor def init self comma name comma breed. So the name and breed gets or the attributes which you are getting from the object, and super.init name. So the name gets initialized in the inherited class itself and the parent class itself, and self.breed gets saved initialized here within the child class. So if I have another method is there called def details. So this gets self.name, which is all there in the parent class, is a comma self.breed. So if I give values like dog, in an object D, buddy comma golden retriever. So the buddy becomes the value for self.name, and golden retriever gets the value called self.breed. So if I call info, it gives animal name buddy, and then if I get d.details, it gets buddy is a golden retriever. So I hope you understood how a super class is working. Super function is working. So this is a we can initialize a parent class even within inside the child class itself. So it's a benefit, okay? So the super function is used inside init of the method of dog to call the constructor of animal and initialize the inherited attribute called name. So this ensures that the parent class functionality is reused without needing to rewrite the code in the child class. So method overloading. Method overloading is a class allows a class to provide its own implementation of method that already exists in the parent class. So this enables customized behaviors while still maintaining the inheritance relationship. So here this is an example. If there is an animal, it makes sound. So here I am having a method called sound which prints animal sound. Okay, but dog, a dog can have a speciality with which it can sound, but in the terms of barking. A cat can meow, so it's different to many animals, but it all have a general characteristic called animal sounds. So if I have, but notice these two methods are common here. So what will happen if if I initialize an object d equal to dog and d dot sound, if I'm asking it what will it the output print? Of course, it will be bark, because the customized behavior is mostly preferred. So this is called method overriding in inheritance. So the animal defines a method sound, and a dog inherits from animal and overrides the sound method. So when d.sound is called, the Python executes the overridden method in the child class instead of the parent class method. Now, as we have saw about the inheritance, let's move to the next topic called polymorphism. Polymorphism means many forms and allows the same method or a function or maybe an operator to behave differently depending upon the object or data it works with. So it is more flexible and it helps with more reusable, maintainable and scalable code. So let's have an example as given in this PPT. So in a backend payment system, imagine that there is a backend payment system. Multiple payment options are available like credit card, UPI, net banking, as well as a wallet option will be there. So all payment types use the common method named process payment, but different implementations. So payment card, if I have credit card payment, it validates card and talks to bank API. And if I have UPI payment, it redirects to UPI gateway. And if I have wallet payment, it checks the wallet balance. And if I have net banking payment, it redirects to the bank login. So each even though all those things have the same method called process payment, each has a specialty and separate functions. I mean separate uses. So this is the main term called polymorphism. See, a method may have many forms, not only a single form. So let's see what are the types of polymorphism which are there. So polymorphism may be broadly described into two parts, which are compile time polymorphism as well as runtime time polymorphism. So here method overloading is a part of compile time polymorphism. We will be discussing about method overloading in the upcoming topics. So method overloading comes under runtime polymorphism. And if you see something different in duck typing and operator overloading, ignore it for now. If there are time, these are the topics which are there advanced. And right now, according to this beginner clause, we won't be discussing it right now. So what are the compile time polymorphism? A compile time polymorphism involves selecting a method or operation before a program execution, typically through method or operator overloading. So the languages such as Java and C++ support this feature. So even though Python does not support this feature, we can mimic some amount of functions which are there in this compile time polymorphism. So that's how is this like this thing. Imagine I'm having a class calculator. So if I have multiply, so the default value given are a equal to 1, b equal to 1. So if I have args, I mean star args is a here star args is an variable length argument. So result equal to a multiplied by b for num in args, result equal to result star equal to num and return result. So what does it do? It create first let's create an object called class. So it gets, I mean if it calls the calculator. So now I am calling print calc multiply. So if I didn't give any value, so the result will be 1. But if I give some values like multiply 4, it prints 1 multiplied by 4, which is 4. But if I give calc multiply, so this args gets a tuple, and for num in args, it returns the required result. So it prints 2 multiplied by 3, it is 6. And if I say calc multiply by 2, 3, 4, so this prints 2 multiplied by 3 and 4. So the output will be 24. So based on the operators, I mean based on the argument which you are passing to the method, the output is varying and then the process is also differing. So this is the main, it is some property which is there for compile time polymorphism. So the next thing is called runtime polymorphism. So which is called overloading. So overloading, I mean we discussed about overloading, and overloading is just an opposite of it, where runtime polymorphism means a behavior of a method is decided while the programming is running, not before not running. So based on the object calling it, so this happens through object overriding a child class. So provides its own version of a method already defined in the parent class. So as we already saw, an animal can make some generic sound, whereas a dog used to bark and cat used to meow. So each has a speciality. I mean within. So I'll be having animals. So dog, cat, and animal. So if I have for animal in animals, print animal.sound. So based on this, I can have bark, meow, and some generic sound. So these are the thing. Even though all these classes have a same, it means I have the same method called sound, it's generically having a different thing. So let's go to the next topic called encapsulation. So right now we have discussed two important pillars of operate object-oriented programming, which are inheritance which reuses a parent class and gets some important things. Polymorphism, which can either overload or override. So overloading is a compile time one, and as well, and overriding is an runtime one. So overloading gets variable type of arguments and we can mimic. Python doesn't support it. Whereas overriding has supports in Python, in which there are repeated methods there in the parent class as well as child class. But mostly the child class value, I mean method, is preferred. So because it is special. So now let's see the next important topic called encapsulation. So encapsulation is one of the core concepts of object-oriented programming. This idea of encapsulation is to bind the data members and methods into a single unit. So this helps in better maintainability. Now the next important topic is called encapsulation. So encapsulation is one of the core concepts of object-oriented programming. The idea of encapsulation is to bind the data members and methods into a single unit. So this helps in better maintainability, readability, and usability, as we do not need to explicitly pass data members to the member methods. So this helps maintain data integrity by allowing validation and control over values assigned to the variables, and it helps in achieving abstraction, and a class can hide the implementation part and discloses only the functionalities required by the other class, which allows us to later changes our representations or implementation without impacting the codes that uses this class. So here is an example which I gave here. So it's a simple example where I'm having a class called employee and a constructor called init, which gets two attributes called name and salary, and self, which is the initial one, gets initialized to self dot name equal to name, and self double underscore salary, which is salary. So notice two things. While we are initializing name, we didn't have any special thing. It's an ordinary one. So this is considered to be a public attribute. But if we have double underscore before that initializing part, it's called private attribute. So I'll be discussing about the advantages, I mean the what are the things which are there in the private attribute as well as in the public attribute later in this part. Okay, so right now see what are things happening here. So here emp is an object which gets which feeds the class attribute, I mean class value employee, with name Frederick and 50,000. So the 50,000 gets feeded into salary and the name gets feeded here. So if I print emp.name, it prints Frederick. But if I print emp dot double underscore salary, what does Python do? It gives error. So why? Because Python, I mean it says attribute error, as an employee object has no attribute called salary. Even though there is a clear visibility of this thing, but actually Python can't access this thing as it's a private attribute and it's hidden from the outside one. So it's we can access, but we can access these things inside the class itself. So this is how encapsulation benefits abstraction. So these things can enable the abstraction. So what abstraction is this? I'll be discussing about abstraction in the next topic. So don't worry what is an abstraction. Right now, understand that encapsulation can enable abstraction methods. So let's have an explanation how these things are there. So self.name equal to name. This is a public attribute, so which can be accessed directly. And self dot double underscore salary equal to salary. So this is a private attribute and these cannot be accessed directly. So print emp name prints Frederick because name is in public. Whereas print emp dot double underscore salary raises an error because double underscore salary is in private as well as in hidden. So why do we need encapsulation exactly? So encapsulation protects our data from unauthorized access and accidental modification. So this controls data updates using getter and setter methods with validation. So this enhances modularity by hiding internal implementation details. So if we have many attributes and methods, and if it is made into a single unit, can we actually see what are the things which are there inside? No, right? Because it is in a single unit. So this is how encapsulation works. So it simplifies maintenance to centralized data handling logic. So this reflects real world scenarios like restricting direct access to bank account balance. So there can be guests or many bank account owners, but a owner can only see it's his own bank balance, not anyone else. So this is how encapsulation works. So there are some access specifiers which we already had some visibility in the previous topic, like in the introductory of encapsulation. Here we'll be zooming in and we'll be focusing this part more specifically. So what is an access specifier? So access specifier defines how a class member, a variable or methods can be accessed from outside the class. So they help in implementing encapsulation by controlling the visibility of data. So there are three types of access specifiers. So what are those three types? They are namely public, protected, and private. We'll be discussing these topics well enough in the upcoming slides. So what are public members? Public members are the variables or methods that can be accessed from anywhere inside the class or maybe outside the class from other modules. By default, all the members in the Python are public. They are defined without any underscore prefix. So we already discussed about public members. So let's move to the protected members. It's the new one, okay? So protected members are variables or methods that are intended to be accessed only within the class and its subclasses, but they are not strictly private, but should be treated as internal. So in Python, protected members are defined using single prefix called self and dot underscore name. So let's see what is a private member. So private members are variables or methods that can be accessed directly outside the class. They are used to restrict access and protect internal data. So in Python, private members are defined with a double underscore prefix. Example, self dot double underscore salary. So Python uses name mangling where the interpreter internally renames the variable. Example, double underscore becomes underscore class name double underscore salary. So this discourages direct access from the outside the class, although it does not create strict privacy like other languages. So let's see how to access private members. And so here is a well example given here. And also with this example, we'll be trying this program our own, okay? So there is a class called employee, and inside employee we have def init self comma name comma salary. So self dot name equal to salary and self dot salary is equal to salary. Self dot underscore double underscore salary equal to salary. So self dot name equal to name becomes a public one, and then this the second statement becomes the private one. Why? Because notice the structure. It's just self.name. There is no double underscore there. Whereas in the self.double underscore salary, we clearly see there are two underscores which are there. So now we can have another one called def so salary. This is a method so that we can get the required salary value from this class itself. So this prints the salary value. So if I give employee Robert, comma 60,000, then self.name gets Robert and salary gets 60,000. So if I print emp.name, it prints it we can access public one, so it's printed. But if I print emp.show salary, accessing private correctly, so we can access this thing also correctly. So but if I give like this statement, it says error not accessible directly. So let's see how we can do it properly. So here is a Python code which I'll be making to create a class called student, where I'll be having def init self, comma name, comma registration number, as well as marks, or maybe CGPA. So here self dot name gets name, then self dot double underscore registration number. Why I giving private one? Because the registration number should be kept private. So I'm giving registration number, and then later self dot I'm giving protected one for CGPA, and for CGPA I'm giving CGPA value. So if I say def get set is done, right? So I'll be saying get. So get registration number. I'll be getting self. So and then I'll be returning self return self dot double underscore registration number. This is a sample program which we have made. So let's see how it is done. So I'm having student variable called Bharat, where the student data will be like Bharat, comma, registration number will be slightly 025467 0245 782. So it's a demo one. So don't worry, this is not my registration number by the way. And I am giving my CGPA 9.59 here. And if I want to access registration number, I mean name Bharat dot name, we can access it. And if I want to access registration number, I mean CGPA, it's simple. How we can do that? It's Bharat dot underscore CGPA. So, but if I want to access private one, Bharat dot double underscore REGNO, will it actually work? Let's see it. So here it says trace back. So Bharat dot registration number. The student has no object called double underscore registration number. Did you mean get registration number? It's asking whether we need to ask this method or not. So it's very simple. What we have to do is that, so instead of that, let's have Bharat dot get underscore registration number. So this function returns the required output. So if I execute it, it gives Bharat 9.59 and 245782. So this is how getter is work. So what if I need to set value here itself? So that's for that itself I'm having setter value. So first I'm giving the self dot double underscore salary equal 50,000. It's a private attribute, and the get will, what does it do is that it returns that self dot salary. But the setter will do, if the amount is greater than or greater than 0, we will be setting that salary is equal to amount. So else we'll be giving print invalid salary amount. So this is how this thing works. So I hope you have understood how private value, I mean private access modifier, access modifier, and protected access modifier works in encapsulation. Okay, so now as we have learned what is encapsulation, so let's move to the next part of the pillar called abstraction. So what exactly is an abstraction? So abstraction is a process of hiding implementation details and exposing only the essential functionality to the user. So this is used to hide implementation details from the user and expose only the necessary parts. So let's have an example. Imagine you own a vehicle. Okay. So what are the things you will visible, which are visibly seen to you? There you can see a door, you can see steering, you can see the you can see the accelerator, brake, and those things. We can clearly see seats. These are seat belt. So maybe those parts are clearly visible to the people. But within inside, like if we want to increase the speed, what will we do? We will just press accelerator. But within the engine, I mean within inside the car or a vehicle, there will be some pistons, there will be some cylinders which work a more and based on the input which you are giving. But we ourselves does not need to know how these things are working. So the things which are there hidden remains to be hidden. Imagine you are having a AC. Okay, in this air conditioner, like we can see if we increase temperatures, we are, I mean, if we decrease the temperature, we are getting colder. But if we increase the temperature, we are getting slightly warmer air. So we know how to do these things. But what exactly happening inside the AC, which remains to be forgotten and then hidden to ourselves. So this thing is called abstraction. So there are some real life examples. So like in the graphics software, multiple shapes are available such as circle, rectangle, and triangle. All shapes share a common data and support the set of axes, but internal details are hidden. So common data like name, color, border thickness, and fill size, and then common actions like draw, resize, and get area. Each shape implements these actions differently. Circle uses radius, rectangle uses length and width, whereas triangle uses base and height. So the software only knows that a shape can be drawn and its area can be calculated. So how the shape is drawn and how the area is calculated is hidden. Okay. So this is a real life example. So this clear example clearly shows how we can how we can implement an abstraction pillar. So here I'm having from ABC import caps ABC, so which is abstraction method. So class greet. So we are having a decorator called abstract method. So we'll be discussing, these kind of thing decorators will be discussed while we are coming to the advanced course. Okay, so right now see that's a decorator called abstract method, that's it. Okay, and we have a method called def say hello and which is passed. So this is an abstract method. So inside that we have class increase, which which inherits greet. Okay, so what does it do? There is a method called say hello self and which returns hello. So if I say g equal to English class and print g dot say hello, so it returns hello, that's it. So there is nothing called greet right now, so this thing is hidden to ourselves. So greet is an abstract class with this method say hello that has no implementation. The English implements this method and returns a greeting. This keeps structure fixed while letting the subclass define our own behavior. So as we have discussed one of the major part in this object-oriented programming, the next part will be slightly different from the object-oriented programming part which we have discussed right now. the next part is file handling. So this file handling is important feature just there in the Python, which refers to process of performing operations on a file, such as creating, opening, reading, or as unclosing it through a programming interfaces. This involves managing the data flow between the program and the file system on a storage device. So ensuring that the data is handled safely and efficiently. So as we have introduced and understood what exactly is a file handling, let's clearly see why there is a need for file handling. So if a data is stored permanently even after the program ends, so like if I want to have an output and after the program ends also I need to use the outputs, okay, as a file, I want to store it somewhere else. So for that we need file handling. So if I have some files like text or csv or json, and if I want to process it and inside the program, we need to have file handling. So if I want to process large files efficiently without using much memory, we will be having file handling. So if I want to automate tasks like reading configs or saving outputs, we'll be having file handling. Okay. So these are the areas where file handlings are mostly worked. So let's see how to open a file. So there is a syntax given, file equal to open and then file name.txt comma mode. So file name or txt is a name or a path of a file to be opened, and mode is mode in which you want to open the file, whether it's read, write or append, etc. Okay. So closing a file. So a file.close method closes the file and releases the system resources. If the file was opened in write or append mode, closing ensures that all changes are properly saved. Okay. So it's very important to have a better, it's an important programming practice. While if you're doing file handling, it's good to use file.close whenever your operations or program is over, okay, so that everything is properly saved. So the next thing, so as we have discussed, there are many modes are there in the file handling. So let's clearly see what and all modes are there. So the first mode which we'll be discussing is R. So R means read and W means write. So if you want to write a program, we use W mode. So if you want to append, like if there is a pre-existing file and if I want to append it, we use A. And X is for creating, like X is a exclusive one where if I don't have a file, it creates a one. But if I have a file, it just works inside it. And read binary. If we want to read or access binaries, we use the read B or RB as well as WB. So these are some example modes which are there in file handling. So as we have discussed how to open a file and close a file, now it's very important for us to reading a file. So here in this example, we have a read method. So this read method reads from a file. So for that, we need to open the file using the file. Okay. So this entire file gets fed into this file variable. And there is another variable called content, which reads the entire content of the file using file.read. So if I print the content, it prints hello world, hello gigs for gigs. So after having a successful program, we'll be saving the file. Okay. So reading a file by line. We may also want to read a file line by line, especially for large files. So where reading its entire content at once is not practical. So those in those areas we'll be using read file line by line. So where we'll be using line.strip. So after having line.strip, what does strip method do? It's nothing but it makes a list of, let's make a list of line by line. So the to each element will be strings, and the comma mentions that it's going to the next line. So let's see the next one. So here it's clearly seen for line in file. So it goes every line, it goes every slash n, and the trailing spaces are new line characters are removed in line.strip, and then it prints the relevant one. And the next example is using readLine. So readLine method reads one line at a time. So we can keep calling it inside a loop until no lines are left. So here in this example, we are opening the file using open gigs for gigs, I mean gigs.txt comma mode or, and then I'm having a like first line where line equal to file.line. So while line, so if I have line, so the line has some specific contents. So it sometimes give true. But if I reach some end of the file, Python, if I are accessing files through Python, the Python generally keeps end of the file value as the end of the file. So we can print line.strip at every point of time in that loop itself, and then the line gets updated again and again using file.reline. So while we are calling it again and again, it goes from one line to the another line. So if I'm having three lines, the first output will be line number one, the second output will be line number two, the third output will be line number three, and after that, as there is no much lines which are there, the line gets end of the file value. So the while loop skips from that one and comes out of the loop. So after that, we'll be having file.close. So this is what happening in this example. Okay. So as we have understood how to read a file, it's very necessary for us to know how to write a file also, as sometimes we need to store our outputs in some files. So for storing some outputs, we need to know how to store, I mean how to write a file. So it's done using the W mode. So this creates a new file if does not exist, or overwrites if the existing file if it is does. So the write method is used to write the content. After writing, makes you to close the file so that the files are properly saved. So with open greeks.txt w as a mode as file. So here with open is an effective way to handle a file, as there is no specific need to close a file. As soon as the program is done, it's very easy for us to just go to the next statement, and by default with does event close functions too. So here I'm having file.write hello python /send. So the first line will be hello python, and then it goes to the next line using the escape sequence /n. The next time I'm having write, I mean file.write, file handling is easy with Python. So after that I'm printing file written successfully. So what kind of output will it be doing? It prints print file written successfully. So this will be the required output. Okay. So I'll be discussing what and all things which are there here. So W mode opens the file, or writing overwrites. I mean, if the file doesn't exist, it just opens it. I mean, it just makes it. But if there are some contents in a file and the file already exists, it erases all the contents like truncating, and then it starts from the first one. So the write method adds a new text to the file. So when using with, the file closes automatically at the end of the block. So these are the things which are there in the write function. So what if, like, there is one major concern which is called overwriting. So if we are using W, it creates the existing content before writing the new data. This is useful when you want to start afresh and replace old information with a new output. But sometimes you specifically need the existing one and you want to continue from where you are left. So for those areas, we'll be having append. So using A, which is append, we can add new data at the end of files without removing the what's already there. So the first output will be created using write mode, and whereas the second one will be the second line appended line. So I hope you've understood why append is used. Okay. So let's see writing, like sometimes now we can't use only writing a line. Sometimes by default we need to go to the next line. For those areas we'll be using writing multiple lines, which is write lines. So write lines are used for, like, if I am having strings or a list of strings to unjoin for building a text block. I mean, okay. So imagine I'm having a variable called lines, where I'm having first line /n, comma second line /n, and comma third line /n. So if I'm having write lines and lines, so it just processes the entire one and it just makes into a single file. Okay. So what does it do? It first prints, I mean first adds line first line and then it goes to the second one and types second line, and then it goes to the third one and stores third line. So if I open file1.txt with write mode, it prints, like if I want to print read, it prints first line, and then it goes to second line and prints second line, and it goes to the third line and prints third line. Okay, so as of now, we have very well finished our file handling lecture. So the next lecture, I mean the next topic, which is last and final one, which is called exception handling. So sometimes, like, there is one major problem in programming, as throughout this lecture series, if I have a program and then in between if I have some errors or exceptions, the Python starts from the first line and goes till where the error happened. After that, it does not continue the next other statements. Because of the one particular statement which causing error, the Python stops everything. So error handling allows a program to handle unexpected these kind of errors during execution and in a controlled way. So instead of crashing abruptly. So using error handling, I mean exception handling, we can prevent crashing. Okay. So this enables program to detect errors, manage them properly, and continue execution whenever possible. So it can handle runtime errors such as invalid input, file not found errors, division by zero errors, and type mismatches that occur during program execution. And it helps improve program reliability by ensuring the application does not terminate unexpectedly when an error occurs. So I have given a some example here for you to focus how error handling actually works. So I'm having a try block. So okay, try block does what and all things which are there, and if there is no error, it just runs. But if there is some error, it goes to the except block. So here I'm having n equal to 10, and within try block I'm having result equal to 10 divided by 0. Notice if I divide a number with 0, it causes zero division error. So it immediately goes to the except block and runs what and all things which are there inside the else except block. So what does it do? It prints cannot be divided by 0. So I hope this example fonts you well and you can understand it good. Okay. So here is a syntax for try and else block. I mean try except else. Okay, I will be seeing what are the things which are there in this each block. So try block, and try block runs riskier clothes. I mean like divisible by 0. These kind of things may happen. If you feel so, you can use try block. And except block catches those kind of errors and handles the error if one occurs. And then else block executes only if no exception occurs in try. Finally runs regardless of what happens, useful for cleanup tasks and closing files. Okay, so let's try one certain example. So here I'm having try, and if I want to get len value of some integers, like if I want to get len value of some strings, like I'm having s equal to integer input enter number. I I on purpose gave input as integer so that I can convert. If I try using len of yes, what does it do? It gives error. How wide does error? See, type error. The object of type int has no len. So instead of crashing, what I'll be doing is I'll be using try len of yes with x equal to len of x, and then print x. So this is the thing which I'm doing here, and the except block I'm having type error. So type error which prints integers cannot be used with len. So this is an type error. Okay. So I'm having an else block. So what does else block do? If there is no exception occurring, the else block activates. It prints no exception occurred. Finally, we'll be having a finally block. So what does finally block do? So finally the block does whatever the main things happening in the try except or else something. It anyhow runs with whatever may be the situation. Okay. So it says code ran successfully. So if I save it and run and give input as 150, it says code ran successfully. Why does do? After that, even though we have done 1 minute, give me a minute. Let me see the exact syntax of type error. So for having like sometimes we need to like Python is a case sensitive one. We specifically need to have the exact name of the error. So now if I give enter a number and then if I enter a number, it says integers cannot be used with len and code ran successfully. Now if I give enter some values and then save and run, if I'm giving birth, it says 6 and no extra exception occurred and finally code ran successfully. So this is one of the things which will be happening in Python. Okay, so in this case I gave s as Bharat. So it does, what does it do? It tried x is equal to len of x. So no kind of error occurred, so it printed the x value and then it goes to, as no error occurred, it didn't even trigger the except block. So it immediately goes to the else block as no error occurred and prints no exception are occurred. So finally it prints code ran successfully. Notice this one. Whatever the may be the situation where the X block or else block are activating or except block are activating, finally block runs in the both scenarios or any scenarios which are there in this exception handling. Okay. So let me go to this example where n equal to 0 and result equal to 100 by n. Okay, this is one I am trying. So if zero division error is occurring, it says you can't divide by 0. And if I say value error, it prints enter a valid number. Okay, if else means it prints what is the result. Finally prints execution completed. So this is sample example program. Okay, so after this, like if there will be some user specified raise exceptions where sometimes the program receives something but because of that particular value the program may go unmatched and illogical. To stop those kind of inputs we can have our own user defined exceptions, I mean custom exceptions, by inheriting Python's built-in exception class. So how does we can do this? It's very simple, like set def set age. If age is less than 0, rise value error, age cannot be negative, and then print age set to that particular age. Okay, so even though -5 is not a value error, but we are convincing that Python program that for this program, if the age value is less than 0, it should result in value error. Okay, so in this try block, we can, if we keep set of 5, what does it do? It goes into this function and then it rises the value error. So because of this rising value error, the except block is triggered and we are printing that message which is there in this program. Okay, which is age cannot be negative. So one such important thing which you have to know is even though errors and exceptions are both issues in a program, but they differ severity in handling. So errors are issues in program in the terms of logic, such as syntax error, etc. These occur at compile time. Whereas exception problems are occurring at runtime. So there are two things called compile time and runtime. So things which are compiled, while after compile only runtime occurs. So errors are first found, okay, and later only these exceptions are found and can be managed using exception handling like invalid input, missing files, etc. So as we have concluded this lecture, as we are going to conclude this lecture, let's have a quick summary of what we have learned in this class. So in this class, we have learned about OOPs. So object-oriented programming is important concepts which uses modularity, reusability, and what may. There is more things which are there. So instead of focusing on functions, we focus on objects, where so objects are the things which are mostly related to real world, like animals, plants, vehicles, or many things. So classes and objects. Classes are things like blueprint. Objects are those instances of a class. Okay. Inheritance. If there is a parent class and we want to reuse that in a child class, we can use inheritance. Okay. The next thing is called method overloading. Method overloading. If there is a method which is already existing in a parent class, but you want a customized method, we use method overloading in the child class. Okay. Polymorphism. There are two kinds of polymorphism, which are runtime polymorphism, which is overloading, and compile time polymorphism, which is overriding. So later stages we learned about encapsulation. What does encapsulation do? It makes attributes, methods, and variables in a single unit. So how does this work? It works by access specifiers. What are access specifiers? Access specifiers are those things which release or restrict certain values from the user. It hides. So what are the access specifiers? Like public is there, private is there, and protected is there. If you want to access protected, private values, we should use getter and setter methods. Okay. So at last we learned about abstraction. So for using abstraction, encapsulation helps in a greater way. Okay, this encapsulation only helps to enable abstraction. So what does abstraction do? Imagine you are riding a car and some things like engine and those electrical circuits which are there in the car are hidden. Whereas those steering and those things which are necessary to be visible to the users are shown to the people. So after this large part of OOPs, we discussed about the next part of the topic called file handling and exception handling, where we learned why it's very necessary for a file to be accessed, why we should learn it, and how to open it, how to close it, and how to read or access it, and finally we learned how to write the file. Okay, so as throughout this course, we have saw some kind of errors which are occurring and then it's crashing the problem. Crashing the problem. So why it's occurring? It's because of exceptions which are runtime. Okay. So to handle it well, we have learned exception handling, where there are three or four things which are like try, except, and else, and finally. Okay. So as of now, we have successfully concluded our Python programming beginner course, and then if I make a new advanced course, you will be learning that advanced concepts very well. Okay. I hope you have learned Python programming very good. Okay. So if you are having any kind of doubts, do let me know in the comments. And I want you all of you to practice the programs and so that you can familiarize, and mostly Python is not a subject to memorize. It's a subject to practice and learn the subjects. Okay. So the previous learnings are the step to the next learnings. So do learning regularly and have fun with programming. Thank you everyone. Have a nice day.